Alright guys, uh, again, I do apologize for the tardiness, but we'll get started here. Today on the Common Lisp study group I think I've been pinging the folks who are on the Slack channel, as well as I think I mentioned it in Discord for a little bit, amongst other channels of communications. We're going to be going through a very small project just to set up how to get a Common Lisp project in to Travis to start doing some continuous integration. I'm going to introduce in this project a little bit about threads too as well, and socket programming. I tried to encompass all this because this is kind of at least for me, I've been doing quite a bit of network programming on a day-to-day basis, so understanding how Common Lisp does this kind of things was an interest of mine, as well as doing multi-threading, which is often, an afterthought when you guys are when we're doing development in a program. We'll start a sequential program and then try to make it concurrent. Add things like shared memory processing. We'll start with a library, particularly that's used a lot in other projects, at least other projects I've seen that are concurrent in nature. That is the bordeaux-threads library. That is a cross-Lisp threads library that will give you low-level primitives to do multi-threaded applications. Additionally, we'll be touching base on usocket, which is another cross-Lisp networking library that will allow you to essentially do socket programming without actually having to know the platform extensions of the particular Lisp that you're using. As usual, if there's any questions and comments that need to be addressed while we're doing this exercise, feel free. The code is available actually at for folks who are on the stream at https:/github.com/rvatum/afpfts. I particularly put this on this GitHub because it's tied into my Travis account, so that I can show you how Travis CI works. Are there any questions at this point? Sweet. All right. I'm showing you right now the initial ASD for this project. The way I set this up is obviously I used Quick Project, which we've talked about in the past. So I'm not going to reintroduce that project again here. But what I will say is here, what you might see is this new property in order to. What this does is by specifying the test operation, I'll be able to actually run things like asdiff test system against this project, and it should actually load up that test file, which is located in a different directory right now, and load that up and run the tests using prove, which is a library that we will be discussing for writing our tests. To get started, I'm going to go ahead and show you that file, which is our test file, and introduce prove itself. For folks who aren't familiar with prove, which I didn't even know that prove was available. I used to use another testing library called 5am. I was going to do that, but prove seems to be far more intuitive than 5am is. Prove was written by the Eitaro Fukamachi, who wrote the Clack library, and it's as well as he's involved with using Roswell, and he's creating an additional testing library called Rove. He created a lot of different Lisp libraries a lot of people have been adopting. This library allows you to create what are called test plans, has single individual Lisp files, and you can create a top-level ASD file, which I'll show you here, that essentially runs like a test suite. It will run each test file one after the other, and these test files will have what's called a plan, and you can run different properties on this plan. Like right now, I only done this dummy example of prove is equals 3 equals 3, just for the sake of showing you how this kind of works. And below, I also have a test case that I wrote for today that we'll be addressing. But this, what it does is it will, if you run prove on the test directory, when you install prove, what you do is you can use Roswell to install this. I've used this to install the prove library. You need to use that independently of when you're setting up your project. And what this does is it creates a command line utility called run prove. So let me show you where it installs it. Run prove is, 1 second, for some reason it's not finding run prove. Which run prove, it should be available. Let me see. 1 second.
Can you show me your path?
Yeah, sure. Echo $path. It doesn't look like it actually has Roswell bin in there.
Yeah, it does not.
Okay, path equals $home/Roswell/bin. All right. Make sure that now finds it. Excellent. All right. This little neat utility, which is installed in Roswell bin, which is where all your applications that are run installed through Roswell will be located. It will take in an ASD file, and it will actually try and run the test case. It will load it into a Lisp image, run through the test case, and then output a report, as you can see here. The reporters there are various reporters. One is like Common Lisp. I think you can get a 5 a.m. report if you're used to using 5 a.m. and you have an integration server that leverages 5 a.m. There's one more style of report that I haven't actually tried. And honestly, for our purposes, and that is primarily hooking into Travis, I think Common Lisp, from what I've read in the documentation, it actually does its thing, and it will collect the test results and actually show off the test results correctly inside Travis's user interface. But if we're not going to be talking about simple examples. Of course, there's plenty of things that we can do here. What I did here is let me just uncomment this guy. Uncomment region is I essentially ran a test case that starts up a new server on a separate thread, and that's actually what start server does. It's a function. It checks to see that the thread is alive, and what it does is it attempts to connect to that server and just quits it. Okay, and that's all it does. It just I have a simple command in that server that quits it. Now this might look kind of dumb as being and it might be very contrived. However, it does a lot of stuff that you would normally do on a day-to-day basis. One is start a thread, pass arguments to a thread, being able to open up a connection to listen in on, being able to grab connections and then act on them from the server side, as well as in this test case, it's showing you how to actually connect to them from the client side to the server once you have the IP address and port. And that's a lot to take in, but we can look at this one at a time, and it'll actually become very clear. Our journey actually begins at this function, this package that I created, the AFP/FTS package. Can everybody see my screen clearly? Like, do I need to increase the font size at all?
I'm fine.
Okay. I just want to make sure. So the main function that we want to look at is, of course, start server. But the other arguments there are simple examples that we're going to be talking about a little bit today and in coming talks as we go through the concurrency library for Bordeaux they will be. I'll show you how honestly those are leveraged too as well to create your standard shared memory processing patterns like producer consumer, reader writer, and so forth. To get things started, the simplest thing about Bordeaux is it follows almost verbatim your standard threads library. If you ever used a threads library like pthreads, or even .NET, if you ever use .NET threads too as well, originally what they used to do is it takes in a function with no arguments, and it will essentially spawn off a low-level, lightweight process that would copy a lot of stuff from the process control block, but it will isolate enough of the memory so that that process can be mapped to an operating system's lightweight process underneath in the kernel level. And it will then pass in whatever arguments that have been instantiated within that process and then execute it. With pthreads, especially, you were able to pass in arguments as separate memory variables inside pthread create. Similarly, what we're going to be doing here is we're leveraging closures to actually pass in arguments into the thread, but the same idea still applies almost as if you ever looked at pthreads. One thing to note about make thread especially is when this gets started, bordeaux-threads actually takes the platform, that is the Lisp image that you're running on, its lower level threads library, and does whatever the lower level threads library of that compiler would do. In SBCL's case, if I'm pretty sure I'm not mistaken by this, that means you are getting the equivalent kind of threads that you would get if you were running this in a like compiled language like C or C++. It will map it to a low-level system thread.
Yes, SBCL uses system threads.
It does use system threads, right? Okay. And that's important to note because that means performance-wise, this should be as fast as if you were, running it concurrently in a whatever compiled language they'll map to system threads to. You should get similar performance. But the difference is and this is something that was kind of interesting when I first started playing around with this, is you can map a lot of stuff from the running system image to the thread itself. So like in this example, this function, what I did is I pass in host and port so you can run different servers in the same running Lisp image. And what I do is I create a closure essentially. I map the host that was passed in as a parameter to the argument server host, and the port that's mapped in from the function to server port. But the interesting thing is I then took the global standard output and I passed it to standard out. Now you might be wondering why I did this, and I'm gonna show this to you because I thought this was pretty neat and something to discuss. Let me just clear up some windows here so that we can actually see this. So let me go and load this guy into my REPL. Right? And let's start our server. 127.0.0.1. Let's say I do 8003. Alright. So when you start a thread inside your Lisp image using bordeaux-threads, Bordeaux actually has a function called all-threads that you can use to query and look at all the threads that are running inside your current Lisp image. You might notice a couple of familiar ones there, like Swank, Sentinel, because we're running Slime. I'm pretty sure what's happening is it ran the server behind the scenes and it's listening in on, and we just essentially made a connection to that server from Emacs. Also, you might see things like the REPL thread for it to actually show you that the Lisp image is running a REPL in a separate thread. our server is actually called command line thread, as you may have noticed in here. The reason is this was an echo server right now, so I couldn't think of. I should call it command line server thread, but I didn't. I was kind of dumb there. So, but what this has done is it took the standard out of the current running Lisp process image, and it actually bound it. And it's running in the thread itself. So now what can happen is, and I'm gonna show this via opening up my shell, and I'm gonna connect through netcat here to our server, because you can actually use netcat to actually connect to the Lisp server right now. And what I'll do is I'm going to set up a simple string stream, make string output stream, and I'm going to go ahead and I'm going to, let me back up the standard output, and I'm going to reset standard output to that string stream. All right. Set standard output to our string stream. Okay. Now we're currently running the main server on a different thread, okay, and it's bounded to standard out, and we just changed standard out. So what one might expect is hey, we changed standard out. Anybody who's not familiar with that, one might expect that when we change standard out, the other thread got changed, right? But that's actually not the case, because what happens is we're doing thread local storage, right? So it actually created a copy of that pointer, all right, where standard out is located, and it isolated it into that thread itself. It's completely now independent of the running Lisp images dynamic variables. Do you guys see that there? Like, this should be familiar to anybody who's done basic thread programming, but it was kind of interesting for me because I didn't know how dynamic variables, especially the standard out and standard in stuff, kind of, if they actually got that also fixed. But it makes sense if you know thread local storage, that this is expected behavior. Are there questions on this? All right. So as you can see here, I'm just running. I created a dummy echo server. It's just, you know, throwing stuff into my standard out, and then when I close it, let me just show this to you right now. There's a function called thread alive that you can use to check to see if the thread is actually alive. And unfortunately, I forgot to actually assign this to a variable, didn't I? One second. Simple thing. We could just do that very quickly. ELT, BT, all threads. So, all right. So my server thread is excellent. So this function, thread alive, will just tell me if the thread is running or not. All right. Okay. When I call quit, as you noticed in this example, what this server does is pretty dumb. It'll keep echoing the current connection, all right? And when it hears quit, though, it will go ahead and close that connection. And as you can see here, I'm not actually looping and looking for incoming connections. This is actually going to close off the server. It's going to exit the server and then exit the function itself. It won't return anything. So when we see this here, we see that it closed the connection, so netcat exited properly and got us to the normal command line. But we'll also see that if we run BT thread alive P, that the server thread is no longer running. And in fact, if you run server thread, it'll tell you finished, has its status. Now, I'm pretty sure that, so one question that might arise is, well, is there any way for me to actually grab the status of a particular thread? I haven't actually seen that in the API docs, but I'm sure that there must be some way. But do you want to do that? I don't know if you do want to do that based on your case. Really, you'd want to check to see if the thread is alive or not, and let your concurrent design deal with waking up threads and so forth, rather than trying to set those properties of the thread objects manually. So let's go through this and really talk through this piece of code in a little bit more detail. So we've talked about how this is a closure and how we're passing in thread arguments and so forth. But how are we actually starting a server inside Common Lisp using usocket? Usocket is a fairly robust networking library that I've used to write very small networking apps. In fact, right now, the reason I picked this example, just to let you know, is that I was trying to port an old project of mine that is a multi-threaded file server to Common Lisp, just to see how Common Lisp dealt with not just setting up sockets and so forth, but how to deal with some of the concurrent primitives that I'm used to using when I'm in C++, especially using pthreads and now the recently added std threads into the C++ standard library. With usocket, the way we do it is very similar. There are some anybody who's done socket programming normally, you create a socket inside your program, whether it be C++ or Python or whatever. Then you do what's called a listen. If you're running server code, you specify usually the host that it should be listening on, the port. You can specify whether or not you should reuse an address or not, and that sometimes is necessary based on what application you're writing. If you're running multiple servers in the same machine, you would need to use reuse address so that it can use the same IP address, even though you're specifying a different port, and so forth. In usocket, it's the same idea. Usocket, to create a socket for a server, you use something called socket listen. Okay. Now you might be asking, well, why are you talking about socket listen without talking about with server socket? With server socket is really just the management of the return value of socket listen. So what you could have done is you could have written you could have written this guy has a let server socket and then do a usocket listen and make sure that you close it at the end of the socket code. However, so you know how I'm using usocket socket code to close the connection. You could do the same thing with the server too as well. But with server socket does that for you, and really that's the preferred way for you to actually write your server code so that the management is done correctly. And that's the reason why I'm leveraging with server socket and with client socket as well. But let's go through socket listen. Socket listen has two required arguments, and they have default arguments for the keyword arguments, primarily reuse address. So you see reuse address and reuse address twice there. The first one is whether or not it's a Boolean, whether or not we are actually reusing the address, and the second one is what address. If I recall what address we are reusing itself. I am right now having a brain fart as to what was that second argument. The third argument, backlog, is for you to actually specify how many connections this guy can listen on, up to which it will start rejecting connections. So like it's in any server, you can maximize the number of connections that you can listen for. It'll have a queue, and after that, it will go ahead and say, sorry, I can't accept any more than this backlog because my backlog is all filled up. So if an incoming connection is already being serviced and the listen socket is not available, it will just queue up that connection saying, okay, after this connection is being done, go ahead and accept this next one and pop it off the backlog. But that's what the backlog is for.
Could you do something for me real fast?
Sure.
Hit Control-C, Control-D, Control-D on the function name. Open the docs.
On this one, or on socket listen?
On socket listen.
Control-C, Control-D, Control-D.
Yeah, scroll down a little. Reuse address is supported for backwards compatibility, but deprecated when both reuse address and scroll down a little.
Reuse address and address is deprecated. Okay, so the reused add, so they're both the same thing. I misunderstood that. Okay.
Yes.
Okay. I was reading the documentation the other day. I wasn't sure what that second one is for, and I was using reuse address.
I just instinctively I pull up the inline documentation whenever I have questions like that. I just wanted to note that for people.
Control-C, Control-D, Control-D. I have to get used to that. I usually have Quick Docs open in a separate tab.
Yeah. Well, there's a much nicer key binding in SpaceX.
All right. Moving along. So listen. A socket listen is a pretty straightforward function. I mean, it just listens on host on port. It binds the particular interface and it starts waiting for incoming connections. When you want to actually accept an incoming connection, you call socket accept. Much like if you called the accept function for a socket inside the standard BSD sockets API. And what it does is it takes in, and let me just go ahead and, since I have that. What this does is it takes in two arguments, the socket object that you're passing in, and a keyword argument that specifies the type of socket that this socket or this connection is going to be bound to. So like what is actually going to be received on the socket itself. By default, the element type is anything, so it can take in binary data or whatever. But I've specifically restricted this type for the time being to character. You don't need to necessarily specify this guy because of the default value, but I'm just showing it to you that if you're really just making like a chat server or something where you're creating commands, restricting it to character is good practice. That way it's a form of documentation too as well, so that people know what that socket object that's being used is for. What it returns is a new instance of a socket. So, and specifically, it's a socket object that has multiple properties. If we want to inspect this guy, what is it? Slime inspect, if I remember correctly. I'm just going to go ahead and do this slime inspect definition on this guy. Slime inspect definition. What? Why wouldn't that work? It should have worked, actually. There we go. That is not what I was looking for. Hold on.
Sorry, I wasn't paying attention. What are you trying to do?
I'm trying to get to the actual usocket code so I could show socket accept.
Alt dot.
Yeah,
Metadot.
That's what I did. That's the generic function I need.
Yeah, just hit down. Yeah, that one. There you go.
Yeah. So what it does is it creates an object to make stream socket specifically, and it takes in two arguments, a socket object, and it actually generates the appropriate stream too of the underlying. Actually, I think that is. Oh, this is usocket taking in and making sure that we're using BSD sockets here in SBCL. Right. So this guy will give you two accessor properties. One is socket-stream, and one is, I think it's socket-socket too as well. But I've been using stream specifically. And the reason is because stream makes it easier to, hold on, here we go. You'll get, you can do socket state on it. You can do socket stream to grab the actual stream version of the socket object. There are, I think those are the only two that's related to the object itself. The other ones are actual convenience functions, and socket error is a class, and condition is a class as well. So what this guy now does, now that we have a socket stream, is we could treat this like any other stream. That means read line is available, read is available, format is available. Anything that takes in a stream argument is accessible by this object, and that's a pretty huge thing. So if you were creating, for example, a fairly large distributed application where, let's say, you have a log server running, listening on a particular IP address and port, you can just create a socket, connect to that log server, wrap it in a stream, and then pass it along. And then if you want all your debug outputs going into that log server, they just need to use the standard Lisp functions to write to that stream, and the Lisp implementation will send that data over the wire. This is different than other APIs, especially if you did the lower level APIs like C, where you have to explicitly call send or send to or receive from. Now, one question I had, and this is certainly an open for discussion because I've only used TCP when I'm dealing with usocket. I've never actually used UDP. I'm guessing, regardless of whether it's TCP or UDP, I can use socket stream. Is that correct?
As far as I know, but I actually haven't used socket stream with UDP either.
Okay.
My instinct about how socket stream works says, yeah, that should actually be just fine, because at least on SBCL, I can see no reason why it wouldn't just work, because what would be going on there is, SBCL is calling, some much lower level thingy to get a handle on a socket object, and that's actually like a file descriptor, right? And the UDP is being handled actually like down at the kernel level, right? And so SBCL can create a stream around any file descriptor socket or file descriptor whatever. If you make a stream out of that, so right. SBCL would at the very least be able to, and as far as I know, I can't see a reason why any other backends wouldn't be able to do that just as easily. So I don't see any reason why that wouldn't just work, but I mean, I don't know. I've never tried it myself either, so.
Okay, so note to self, I'm going to have to try this just to make sure. But theoretically, it should work, folks. If you're
the
doing
only reason it wouldn't is because of laziness on the part of, the usocket people.
Right.
And honestly, like, streams are so fundamental to text processing in Lisp that it would be very weird to me if they hadn't.
Yeah, but with UDP, you're not guaranteed any of that transmission, so I would doubt that they would be doing the resends or handling any of that.
Well, yeah. Well, so, I mean, the
stream could be completely corrupted. Basically, if you just took a stream object and tried to use it. I mean, like I'm saying, it might work, but I don't know if you probably want to do that with UDP.
Yeah, you may not want to do that with UDP because you might get totally junk data. Sure, yeah. But there's nothing stopping you. The UDP socket down at system level shows up as a file descriptor just like a TCP socket does. And you know, the stream is just a wrapper around something that has read and write calls.
Well, I need to do more experimentation on UDP just because, again, most people, the reason I'm showing you guys streams is just because, one, I'm familiar with it. Two, I know that TCP works really well. And three, it just shows off how well integrated usocket is with the rest of Common Lisp. I mean, it just works. This code took like literally 10 minutes to just whip up and just to show you how. And I didn't have to rewrite anything. I didn't have to override anything in Common Lisp to get the socket stuff to actually just work. The usocket folks have made it fairly well integrated. And it's the same thing. Like you could see where if you look at any of the implementation inside usocket for different networking libraries out there, they do something similar too as well. But again, I'm bringing up UDP because that's also the other side, right? We can't forget datagrams. We gotta. There are cases where it's actually useful for you to actually do unreliable connectionless delivery. So that's where UDP would come in, and that's a little bit unknown for me just because I never had the use case to actually go and leverage that, which is why I'm bringing it up too as well for discussion. So this is a very basic code. Obviously, we can totally do some interesting things like we can expand this guy so that it can continue listening on connections until it receives something from the socket. Actually, I would probably do it differently here. I would not do it there. I would probably put it in here so that I could do a loop and then check to see if quit server actually gets assigned differently. We can add multiple connections, multiple threads too as well. But I wanted to, before we start extending this, also show, well, how did this actually get hooked up and actually gets tested? Because I just showed you how our test script looks. I just showed you how our code actually works. Well, how does this get tested if we want to do continuous integration? For that, we have Travis. Travis is, a standard continuous integration server. This is there are examples of using also Jenkins too as well, but I'm using this just because it's a little easier to. It has better GitHub integration than setting up a standalone Jenkins instance and configuring that. Although if folks are interested in seeing Common Lisp integration with Jenkins, let me know, and I will come up with an example as well for that too. This is a pretty standard continuous integration system. How you actually go in and hook into it is you leverage a YAML file, you load it into your Git repository, and then what you do is inside the Travis user interface, which I'll show you shortly, you can add in a new project for it to actually go and pull from and then run the test results for. This actually does have currently one bug that I apologize. I tried to get in fixed earlier, but due to some other prior engagements, I was unable to fix. So I'm going to fix it tonight and then check it in. But it does show off the skeleton of what you would normally do when you want to set up such a test implementation. Primarily, let me just start from top down. You specify the language being Common Lisp, and you specify whether or not you need sudo or not. What Travis does is for each environment, each in your test matrix, it'll create a new virtual machine with that specific Lisp installed, and it will then install additional utilities based on what we see later in the install step. The first thing that you would notice here is our environment. This is where you would specify all your environment variables when you first load in Travis, so that Bash will actually have the appropriate paths all set up. This coverage exclude is particularly if you want to use code coverage. Right now, I'm not using code coverage just because it was a fairly simple example. But I received this from a template that was that showed off how you would actually end up using code coverage, and I was going to go and add that into as well as a feature, but time didn't allow me to do that. The next thing you would see is all the Lisps that you would want to probably test on. As you can see, I'm specifying sbcl-bin, ccl-bin. These are notations for Roswell specifically, because I'm using Roswell in this Travis YAML. What it does is it will actually go and install that Lisp later on in our install step. But before we get to that, one more thing I wanted to show is this matrix of allow failures. If you know that a particular piece of code that you've written is specific to a particular Lisp, and if that code is being run in other Lisps and you haven't actually put in the guards in to ignore it when you're compiling it, you can go ahead and set up this allowed failures matrix so that Travis will ignore those failures and just move on. It'll give you a report saying that it failed, but it won't like spit out anything major about it because you said that you allow failures on that particular Lisp. The add-on section is what you essentially leverage. Again, like I said, it creates a new virtual machine, and if you need additional dependencies, this is where you would go and install them. This is through app specifically. If there's, like, let's say a C library that you're using that's required by a Common Lisp wrapper, like, I don't know, Common Qt or Qlot, I think, also uses a Qt dependency. This is where you would specify the list of packages that you would want installed ahead of time before you set up the actual Roswell environment and then install your code. Next, we'll then, in the install step, now, I'm just quickly brushing through this. There are additional steps in between the steps. Like, for example, after the add-ons, Travis has a before install. If you want to run like previous test scripts, you can go and do that. There's a before script too as well, where you can add additional test setup where, like, let's say that you're downloading data or so forth. But I'm ignoring those right now because those aren't really necessary for our particular use case. Install will go in and then to Roswell, install it, install as dev. It'll go and install our command line utilities using Roswell to particularly prove and run prove. And then this particular piece here is where we would be installing our project. Now, those of you who are forking the repository, I will warn you, you may need to change this because obviously this cloning is cloning my project directly rather than your fork of the project, so you may need to adjust the script so that if you're going to try this on your own Travis instance, it will run and it'll actually pull changes from your particular Git repository rather than mine. But I'm mentioning it here right now that Travis by default should normally do a pull. I didn't see it actually do a proper pull, so what I did is in the install step itself is I attempted to do a pull if the directory exists. Because what Travis does is once the initial setup is done, it just leaves that virtual machine alone. It actually stays idle until the next time you do a commit, and then it will spin off another job with that environment intact, and then run through the test suite again. Cache is what you expect the Travis build to actually go in and save between test builds. In this case, I'm having it save off my .roswell directory as well as my config Common Lisp directory, just so that cache versions are okay. I noticed this in a lot of Fukamachi stuff. I'm not entirely sure why he does this, but before script I used as a safety handle just to test whether to report off the Roswell version I'm testing against and the Roswell configuration. I guess from one standpoint, if you have a very detailed test matrix, this information is useful. If you don't, you can actually go ahead and leave this out. But it's definitely useful for more reporting. Finally, we have the script section, which will then allow us to run command line utilities. In this case, I'm using the command line tool runproof to actually go and run through the test suite. So this is a very basic Travis YAML. It's not too overwhelming, but I'm going to show you. If you just bear with me for a second here, I'll need to go and show you my Travis CI web page so that you'll see how this looks like. So just give me this 1 second here so I can share my screen with you folks. In the meantime, while I'm setting up, if there are any questions or discussions, feel free to, talk amongst yourselves. Okay. All right. Can you guys see my Travis screen here?
Yep, you're good.
Sweet. Excellent. This is what Travis actually looks like. It's a pretty simple dashboard. You can see that you can add a new project by going to by clicking on specifically the plus icon, if you notice here, that I clicked on earlier. And what that does is it will go, and if you've synced your GitHub account with Travis, it will have all your projects that you're actually you have either a fork of or you actually directly develop on. And you can search for your project. In this case, AFP-FTS is the project that I was looking for. And if you click on this guy, you can do what's called activation. And activating the repository will then bring you to this screen, where it will also automatically allow you to start off a build. So that way, every subsequent time, it will then it has behind the scenes a watcher. It'll check to see if something was committed. Then there's a trigger that will essentially say, okay, something was committed. Let's spawn off a new build. Travis does all this stuff for you behind the scenes already, so you don't have to go and set that up yourself. It does the triggers and to pull from GitHub directly for you. So there's no real additional setup. If you want to manually restart a build, like I'm going to show you here now, what it will do is it will manually start it. And if you noticed here, because I specified 5 different Lisps, it started 5 different essentially machines that will concurrently run through actually installing, cloning the repository, and even any changes if it in the case of pulling it, and then if it needs to change any dependencies, it'll go and change any dependencies. Basically, we'll follow that travis.yaml file and then run through the test cases that through runproof. So essentially, we'll run the same thing that you would normally run if you ran your test suite on your own machine. Any questions? This is a basic skeleton of how you would set up a project. But so I do hope you guys understand this, and so please ask away if there are any questions.
We're having trouble getting anything from you.
Can you hear me? Hello?
We can hear you, Ram. George, your mic's not coming through.
Can you hear me now?
Yes,
There
I
you
can
are.
hear you.
All right. I'm going to mute to avoid problems.
All right.
I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems. All right. I'm going to mute to avoid problems.
Okay, 1 second. I just noticed one thing. There we go. Okay. So, now, George, you saw this anywhere? Like, were you able to try this out last night after we discussed this? Like, did you try it today?
I went home to sleep.
Yeah, I figured. Sorry, it was late last night when we got done. So, but did you get a chance to try this? Like, it's pretty straightforward. Again, you add your project here, you go through, and then it will set it up into your dashboard, and you can then start off a build, and then from then on, every subsequent change that you make will trigger another build. And as you guys can see here, obviously, once test pass, you'll start seeing, the test suite. This is your standard continuous integration server, guys. So there isn't much for us to do here. Mainly, it's I wanted to show off that you could essentially test against multiple Lisps, especially if you set it up this way through Travis itself. Of course, if there's a particular failure on a Lisp, you would have to have the environment on your local install. But if you don't, and you want to constantly run tests every time you make a change and have it run through another build, go right ahead. Whatever floats your boat. Cool. So I want you guys to play around with this a little bit, and what we're going to do is, and I apologize, I really didn't want to, because of the lateness, I didn't want to take too much time. I want to still stay within the 5:30 to 7 time frame. Starting next week, we're going to start extending this. We're going to actually add the support for file servers, and we'll start talking about how to probably even leverage usocket a little bit more, and hopefully, and I don't want to make any promises, depending upon the time, because again, unfortunately, I had a couple things here that ended up delaying today's discussion. We can start talking about object serialization, so that we could send objects across the socket too as well. Because obviously, once you start talking about files, the next thing is, well, what about arbitrary Lisp objects? How do we handle that? It will be a next logical question. So we'll touch base on that. Are there any final comments? I know this is a very short talk, but given the time frame, I didn't want to take too much of folks' time, given the fact that I ended up starting really late.
No, I'm fine. Thank you.
Jerry, I noticed we have a newcomer here.
Yeah, Jerry is actually at Freeside with me, but he's away from his computer right now.
Oh, okay. Well then, if there's nothing else, I'll talk to you guys next week. I do apologize for the short one today. I didn't think that I would be delayed this much by some maintenance that are being done on my apartment. But hopefully next week we can start on time, and we can actually move quickly through the project and add some additional features. Okay, cool. I will talk to you guys later, and thanks for joining me at this late hour.
All right then. Bye.
Okay, bye.